Hi everyone, my name is Mikio. In this video, I will explain how to use PyTest various options that can increase your productivity when testing your code. In this video, I'll explain how to run tests selectively, how to use useful command options, how to use markers to select test functions, and how to use the configuration file pytest.ini. First of all, let's have a quick look at what PyTest output looks like when it runs without any options. Just for the explanation purposes, let's use the following trivial tests. When you run this test file using PyTest, the output will look like this. The first part is the header, which shows the version of the Python interpreter and PyTest, and where the root directory is. Then you see the test file name and its result. The dot means that the first function passed, and the following F means that the second function failed. Then there is a summary section including the traceback, which I'll explain more later in this video. PyTest offers various ways to specify which test files to run. By default, PyTest runs the tests in the Python files whose names start with test underscore in the current directory and its subdirectories. Now the current directory contains only one test file, test underscore basic.py. So if I run the command pytest, it will run the test in this file. If you want to run test in a specific file, you can specify the file name in the pytest command, and pytest will only run the specific file. You can also specify a directory name, and PyTest will run tests in the files in the specified directory. For example, if I specify the current directory name, it will run the same file. You can also use the -k option to specify part of the file names to choose specific files selectively. For example, let's create another test file called test_advanced.py, which contains one test function like this. In addition, let's create a subdirectory called subdir and create another test file called test_subdir.py like this. So now I have test_basic and test_advanced in the current directory, and another file called test_subdir in the subdirectory called subdir. So when I run PyTest, it automatically runs all the test files by default. If you specify the option -k basic, for example, PyTest will run only test_basic.py. But if I run -k subdir option, PyTest will run only subdir, test_subdir.py. PyTest has various command line options which mainly control how PyTest runs and what information you see in the output. Here, I will explain some of the most commonly used options. You can make the PyTest output more verbose or less verbose, depending on your needs. Now, let's assume that we have the following functions in test_basic.py. When you run the PyTest command without option, you see an output like this. But when you run the PyTest command with the -v option, you'll see an output like this. In this case, you see the file name, the function names, and the test result. But if you want to see less information, you can use -q option. This time, you can only see the test results and traceback. This option might be helpful when you run hundreds of tests regularly and just want to see the summary of the test results. But if there are errors, you can still get information to find out what went wrong. If you don't even want to see the traceback, you can use the -no -summary option like this. The -l option shows the actual values in the local variables in the traceback. So when tests fail, you can see what values were used at the time. This example is maybe a bit too simple to see the benefits, but if you have more complex functions in the tests, it can save a lot of time to analyze the cause of the test failures. PyTest captures standard output from the test function, such as print statements, and shows it in the summary info section. But it might not be very obvious, so let me show you how it works. Let's add a print statement to the test_basic.py file like this. Then run PyTest. Here you can see the section capture stdout call after the traceback in the failures section. And it includes the text in the print statement in the failed test. But you don't see the print statement output from the past function. So just to make the output easier to read, let's remove the failing function from the test_basic.py file just for now. So when you run PyTest, you don't see the print output by default. To show the print output for the past test, you can use the -rp option, which means summary info for the past test with output, like this. Alternatively, you can use -ra option, which means summary info for all tests as well. You can now see the print output in the captured stdout call section in both cases. You can also use -s option like this. This option tells PyTest not to capture the standard output, so you can see that captured std out call section does not appear in the summary info. Instead, you can see that the print output right after the test file name, although the output in the summary info would probably look nicer. This -s option might serve the purpose in some cases. PyTest has the built-in functionality to mark test functions. Markers are like tags, which you can use to categorize your test functions into different groups. PyTest provides various built-in markers, but two of the most commonly used markers are skip and xfail. So I'll explain them first, and then I'll explain custom markers. You can use the skip marker when you want to skip specific tests. Then PyTest will exclude the marked functions, but will show that they have been skipped. So you might want to use this marker, for example, when some external dependencies are temporarily unavailable and the test cannot pass until they become available again. To mark a function as skip, you can use the pytest.mark.skip decorator like this. And be sure to import PyTest in the test file. When you run PyTest with the -v option, you can see that the function that marked skipped is shown as skipped. If you run PyTest command without -v option, you'll see S instead. If you add the -rs option, which means extra summary info of skipped functions, you can see an additional section about the skipped function. You can optionally specify the reason to skip the function like this. In this case, just adding reason, just skipping. Then you see it in the summary info. If you want to skip specific tests based on some conditions which you can determine within the code, you can use pytest.mark.skip if decorator. For example, there might be a situation where you don't want to run some tests on a particular operating system. You can use sys.platform with the pytest.mark.skip if decorator to automatically skip platform-specific tests. So here, let's say you don't want to run tests on macOS. Sys.platform returns Darwin on macOS like this. So you can specify skip if like this. Then when you run PyTest, it will skip this function on macOS. You can skip tests when you already know they will fail, but do not want to remove them from the test suite. For example, you might have a test that fails because of a bug in the code. You can mark it as xfail to acknowledge that it will fail until the fix is implemented, but keep it in the test suite. Let's add the xfail marker to the test function like this. When you run PyTest, the result is shown as xfail. You can use the -rx option, which means extra summary info of expected fail functions, to see additional information. To simulate the situation where the bug has been fixed, let's update the test function so that the assert returns true. When you run PyTest, the result is now shown xpass. Xpass means unexpectedly passed. It is because the test now passes, but it is still marked as xfail. So this way, you can find out that the fix has been successfully implemented, and therefore you can now remove the xfail marker from the test function. You can define your custom markers and use them to categorize your test functions into different groups. So let's add a custom marker called basic. Here I have 3 test files, but when running the PyTest command with the option -m basic, only test_basic.py is run. You can also see the warning, but I'll explain how to fix it later in this video. You can also specify -m not basic to exclude this function like this. Now, test_basic.py is excluded and the other 2 test files are executed. As you have seen so far, you can specify various options when running the PyTest command. But if you run the same command regularly, it is not very convenient to manually type all the options every time. PyTest has a configuration file to keep all your settings, so let's use it to save some typing. There are several ways to save configuration, but in this video, we'll use pytest.ini.file. First of all, it's helpful to understand how PyTest determines which configuration file to use. Let's create an empty file called pytest.ini in the current directory like this. I'm using the current directory here. Now run the PyTest command without any arguments. In the header of the output, you see the information about root dir and config file. It confirms that PyTest is using the configuration file pytest.ini in the current directory, which is this directory. You can actually place pytest.ini file in the current directory or any one of the parent directories. PyTest will find it and sets the root dir to the directory where it finds the pytest.ini file. Most of the cases, pytest.ini is placed in the project root directory, but in this video, let's use pytest.ini in the current directory. Now let's add the add ops option to the pytest.ini file like this. Then run the PyTest command without any arguments. As you can see, the output is the same as the one when you specify the -v option, even though I didn't specify the option in the command line, so it saves a little bit of typing in this way. You can specify any other command line options to add ops. So far, we have been using test files in the current directory and its subdirectories. But you'd probably want to keep all your tests in a specific directory, such as test. You can specify the directory in the pytest.ini file, so PyTest doesn't waste time searching test files in other directories. Let's create a subdirectory called test in the current directory and move the test files there. So the current directory structure looks like this. I have two subdirectories, test and subdir. In test, I have two test files, and in subdir, I have one test file. Then add the test path option in pytest.ini file like this. Now run the PyTest command without any argument from the current directory like this. So you can now see that test path is set to tests. Collected 2 items in the header is the correct number of test files. The results are shown only for the test files in the test subdirectory, and PyTest ignored subdir subdirectory. Up until now, I have been using test files with the prefix test underscore, such as test underscore basic.py, but this prefix is configurable. Let's add the Python underscore files option to pytest.ini like this. PyTest will now search files with the prefix a underscore and consider them as test files. Then let's rename one of the test files in the subdirectory tests. So the files look like this. Now, run PyTest without any arguments. You can now see that PyTest only found and ran one test file, which is a underscore basic.py in tests directory. Likewise, the function name prefix is configurable. Let's add another test function with the prefix my underscore to the file a underscore basic.py like this. When you run PyTest, you can see that it does not pick up the newly added function. Now let's add the Python_functions option to PyTest.ini. When you rerun PyTest, you can see that it now runs only the newly added function. When I added custom markers earlier in this video, you might remember that there was a warning in the output. You can eliminate this warning by registering your custom markers in the PyTest.ini file. Remove the Python files and Python functions options from PyTest.ini. Then rename the test file back to test_. So the test files look like this. So now let's add a custom marker called basic to the test file. As we saw earlier in this video, running PyTest with -m basic will pick up only the functions marked as basic, like this. And you can also see the warning here. It means that the marker basic is not registered, so PyTest is asking whether it is intentional or it is just a typo or something. In this case, I'm sure this is not a typo, so let's register this marker in PyTest.ini file to remove this warning. The text after the colon is an optional description of the marker, and it is generally a good practice to add explanations so that the other people in the team, or often yourself in the future, can understand what it is and why it is necessary. And then run PyTest. So you will no longer see the warning because the marker is already registered. And then lastly, when running the PyTest command with the ---- markers option, you will see all the markers, including the custom markers I just added here. In this video, I explained some of the options that PyTest offers to make your test activities more efficient. First, we looked at how you can selectively run tests. You can specify the file name or directory name in the command line arguments. You can also use the -k option to identify a part of the file names. Then we looked at the PyTest command options to change the output. You can use the -v option to make it more verbose, and the -q option to make it less verbose. You can also use the -l option to see the values in the local variables in the traceback. You can also capture the standard output and display it in the result. One of the powerful options we looked at next is markers. You can skip specific tests by adding PyTest marked skip or PyTest.mark.skip if decorator. You can mark failing tests as PyTest.mark.xfail. You can also use custom markers to group your tests and selectively run them. Finally, we looked at PyTest.ini file where you can save your settings. You can find more information in the PyTest documentation. I hope you find some of these options in this video helpful and continue exploring other options that suit your needs. That's it for this video. I'm Mikio and thank you for watching.